sir.
Okay.
Dear students, so we have with us a very eminent teacher and also an experienced faculty in the domain of embedded systems, real-time systems, so electrical vehicles and IoT. Sir has a lot of consultancy projects. Sir has delivered a lot of talks to the industry personnel. So he has worked with ARM boards of different versions, Cortex M3, M4, and Sir has taught the subject for multiple semester students in the domain of electronics. So we are fortunate to have Sir with us. So I requested Sir to give overview about ARM processor families. So we are just studied in our theory ARM 7 and take an example of LPC 2148. But ARM is so powerful. So by listening to Sir lecture, we understand that. So there's a lot of scope in learning ARM different families of processors. Sir, please go ahead.
Okay. Thank you, sir. So that is an exhaustive introduction to me. Anyway, ಅಷ್ಟೊಂದೆಲ್ಲ ಏನೂ ಇಲ್ಲ. So I'm a faculty in Department of ECE, and I will be handling the courses related to embedded systems and computer architecture. And today, sir requested me to give some information regarding ARM processor families. Okay, and you must be knowing that the ARM company is not manufacturing any silicon. Rather, its business is into design of CPUs and design of many IP cores, and there are third-party vendors are there whose job is to take the license of this core and put the different peripherals around that and convert that to a silicon. However, the ARM company is consistently upgrading its cores to match the requirements of the industry, so that ARM company or ARM cores are ruling in the market. So in today's lecture, I try to give some introduction regarding ARM processor families. Okay, and then moving ahead, I think you must be aware of ARM processor families. ARM is majorly selling 3 different types of cores which falls under category of Cortex. So it's called A profile, ARM Cortex A profile, ARM Cortex R profile, and ARM Cortex M profile, where A stands for application and R stands for real time and M stands for microcontroller. So when it comes to Cortex A profile, so this is the very famous processor core used in the mobile phones. If you take an example of Qualcomm Snapdragon or Samsung Equinox, which are very famous in many of the mobile phones, which are using this Cortex A core in addition to other cores. Please try to understand. When I say the mobile SoC, it's not only a Cortex A core, it's having other chips also to support the mobile kind of operations. What made this code used in these kind of applications is, you take example of laptop or computer. Okay, in the laptop or computer, RAM will be there, and you must be knowing that before execution of anything, any software, anything as such, it is usually stored in the hard disk that is brought to the main memory. But size of the main memory will be usually lesser than the software what we wanted to run. For example, take a MATLAB. MATLAB will be usually running into several GBs, but available RAM memory in the computer C will be lesser than the size of the program, like a MATLAB what you want to execute. So what is practically done is to run a program which size is more than the available physical memory. So the program is partitioned into several portions, and only the portion that is required for current execution is brought to the RAM, so that CPU can execute. But this portion of this type of execution is called virtual memory support. And to have this kind of support in our systems, we need an operating system which supports what is called as memory management. So if our application demands these kind of requirement, that is memory management unit or a virtual kind of memory support, then Cortex A kind of CPUs are very much suitable. What I mean to say is, if our application demands use of OS kind of applications, or if you want to execute a rich set of operating system features, then Cortex A CPUs are useful. That's the reason why Cortex A series CPUs are used in the mobile phones, because in the mobile phones, we need a support for running variety of applications, plus we need a support for OS kind of operations. And very famous, and you must be knowing that the Raspberry Pi what we're using among the student community is having Cortex A series of core. Why? Because in the Raspberry Pi Raspberry Pi also requires execution of the OS kind of applications. Okay, so whenever your requirement or application demands usage of rich kind of OS kind of features, then we can think of using Cortex A series of core. Other famous application of Cortex A series of core is the infotainment system of cars. That many cars, the dashboard is not anymore dashboard. It has become what is called as infotainment system. It provides information plus entertainment. Plus recently, addition to that, there might be a navigation maps also. To support these kind of diverse requirements, we require OS kind of support. In these kind of applications, Cortex A series of cores are used. Okay, and performance, what is expected out of this Cortex A profile CPUs is very high. I mean, they can provide high throughput. Okay, compared to R profile, which stands for real time, there are a couple of other applications are there in the market. For example, if you take an airbag deployment of the car, okay, after crash is detected, okay, the time available for the airbag deployment system to deploy the airbag is typically 30 to 50 milliseconds in the worst case. So that means airbag has to deploy within 50 milliseconds. Otherwise, we will be knowing that if the airbag is not deployed after crash detected within 50 milliseconds, that's a catastrophe can happen. That's a life of the driver who is driving the car. Okay, if you want to support these kind of applications, so you want a microcontroller or you want a processor core which can provide faster response time. And these kind of applications are called odd real-time systems, which are very critical. What I mean to say is, if this system fails, the system fails to respond within that predefined time of say 50 milliseconds in the case of airbag deployment, and we can assume that what will happen to the driver. Okay, so these kind of critical systems, which falls under category of odd real-time systems, Cortex R series of cores are provided by ARM company, which are set to provide faster response time. Plus, there is one more very important parameter called reliability. That means the calculations what are provided by these kind of cores are very reliable, very accurate. And the applications like the odd braking systems in the cars, plus the real-time the airbag deployment. In addition to providing the fast response time, we expect the system to perform the calculations very accurately. Okay, so think of the what I mean to say, ASIL-D kind of safety features available in the cars. In addition to providing faster response time, there is what is called as functional safety. That means, the system has to work properly in all the cases, whether you are running the system for 100 times, 1000 times, or you're using the same system for 15 years throughout the lifespan of the car. The system has to work properly. In these kind of applications, ARM is providing Cortex A series of core. Okay. So in addition to this, so to provide what I told, the ASIL-D kind of functional safety in the automobiles, like airbag deployment. Airbag deployment should not fail even in one time also. So these kind of applications are called ASIL-D kind of applications. That level starts from A, extend up to D. D is the highest level and A is the lowest level. Okay, so ASIL-D kind of applications, R type of cores are used. In addition to provide what is called reliability, as I mentioned, usually the multiple cores are used. So multiple cores will be not active always. Rather, one core will be active and other core is called as a lockstep core. It is working as a redundant core that come into picture only when one main core fails. So this is called lockstep core. Many Infineon guys are manufacturing these kind of microcontrollers, which are based on Cortex R series of CPUs, which are used in automobiles. In fact, NXP is also manufacturing microcontrollers used for automobiles. Texas Instrument Sitara is based on Cortex R series of CPUs. Remember, whenever you want a real-time performance, Cortex R CPUs are used. Okay. Other very famous ARM Cortex processor family is M profile, where M stands for microcontroller. So what is the meaning of this microcontroller is, wherever you want to, where we can think of an application which are based on the microcontrollers. So those kind of applications can be built using the Cortex M series of CPUs. So to be frank, so ARM company is ruling in the microcontroller market. Cortex M CPUs are ruling in the market. There are many vendors are there. who will manufacture the microcontrollers which are based on the Cortex M series. The very famous is ST Microelectronics, so it manufactures ST series of microcontrollers which are based on Cortex M series. Or Texas Instrument is manufacturing, NXP is manufacturing. In fact, Infineon is manufacturing, Honeywell is manufacturing, Renesas is manufacturing. So please try to understand. So one reason why ARM is very famous in the market is it is consistently upgrading its core to match the requirements of the industry. Plus, there are many players are there in the market who are supporting the ARM cores. What I mean to say is, take example of ST. ST Microelectronics is a company. It has its own cores. In addition to its own cores, it makes use of the ARM cores to release the microcontrollers to market. Okay. In addition to releasing the cores microcontrollers to market, which are based on ARM, it also manufactures, it also gives software tools to use or develop applications on these cores. So there are many players in the market who are supporting the ARM cores. Plus, many players are there who are actually silicon vendors who will provide microcontroller chips or processor chips based on the ARM. That's why ARM company is ruling in the market. Okay. To be frank, I can say ARM is a monopoly. So to breach this monopoly only, in the current market, the RISC-V is gaining its momentum. Many companies have started working on the RISC-V. That is because it's open source. Nobody is not to pay any royalty to take the license of it. Okay. So please try to understand. There are three profiles: are Cortex A series, R series, and M series. Where A stands for application, R stands for real time, and M stands for profile. Out of these three profiles, Cortex M series is very famous in the microcontroller market segment, and Cortex A series is very famous and the mobile SoCs, which are designed by different companies like Broadcom is doing, Qualcomm is doing, and Samsung is doing. So they will manufacture their own SoCs which are used in mobile phones, making use of Cortex A series of profiles. Okay, these are very famous Cortex processor families. So in addition to this, ARM has recently introduced two more families which are not necessarily belongs to Cortex family. One family is called NeoVerse. NeoVerse is the ARM NeoVerse, and second family is called ITAS. As I told earlier, ARM is consistently upgrading its cores to meet the requirements of the industry. And recently, the ARM wanted to enter into the server market and data center market. Earlier to this, the Intel is still ruling in the server market and data center market, and its ARM started designing NeoVerse cores to compete with the Intel to enter into the servers. Okay, and ETAS is recently added to the ARM processor families to support ML kind of applications. And if you know that now the most of the applications which are in market now will be having the minimal ML application, and to have these kind of ML applications, a CPU what is used in these applications must be capable of performing wide variety of processing operations. What I mean is that throughput should be high. To provide this kind of throughput or computation power, what is required for machine learning kind of applications, ethos is there in the market. So I think nobody, no silicon vendor yet manufactured IC based on NeoVerse or ethos, whereas we will find ICs based on Cortex A series, R series, and M series. There are many players are there who are making of this. So, and ethos, I think Renesas is trying to release a chip which is based on ethos, which is used for neural processing unit, especially used to perform ML kind of applications. Okay, so please try to understand. So the previous three families, what I told, Cortex A series, R series, and M series, which are very famous by ARM companies. Okay, so moving ahead, this slide shows different Cortex families which are there in the market. Now the ARM7, what you discussed, which comes under category of classic ARM processors. Please try to understand. ARM7, ARM9, and ARM11. So these comes under category of classic ARM processors. Most of the industry guys are not using these classic ARM processors. Rather, they are using the processors which belongs to Cortex family. In the Cortex family, as earlier discussed, we have Cortex M and Cortex R and Cortex A. And if you see along the y-axis, As we compare Cortex M with Cortex A provide high performance and compared to R and M, and R will provide high performance compared to Cortex M. So that is the requirement. So what is the meaning of that is Cortex M series of microcontrollers are used in the applications which are typically embedded, where we do not expect the performance of the CPU very much similar to the processor that is used in the laptops or computers. So these laptop or computer CPU is supposed to have very high throughput. Okay, that means number of instructions it can perform in a unit time must be high. That's the reason the performance or the capability what is provided by Cortex M series of CPUs is lesser compared to R and A. So inside the Cortex M, so there are many variants are there, starting from Cortex M0 to Cortex M0 plus, M3, M4, and M33, M23, even M85 is there, M55 is there. As I told earlier, in all the Cortex series, ARM is consistently upgrading different cores which matches the diverse requirements of the industry. So in the Cortex R series also R4, R5, R7 and R52, many are there. In the A series, A8 to A72 and A73. In fact, Raspberry Pi 4, what is there in the market now, is housing Cortex A series of core. In fact, Raspberry Pi board is having Broadcom SoC. The SoC is having Cortex A series of core plus one DSP core will be there, that digital signal processing core powered by Texas Instrument. It's actually a multi-core chip. Okay, so as I told, you can see the different application domain. So the M series is used in the applications which are typically embedded. Okay, and for real-time applications, the Cortex R series is used. And for applications where we expect a memory management unit and where we need a features to support rich kind of OS operations, we'll use Cortex A series. Okay, so classic ARM processors which are not industry relevant, but what the market currently the people are using Cortex M series. Okay, so moving ahead. So this is, as I told, different application domains of Cortex A series, R series, and M series. Please pay attention here. So the Cortex A series, we can see it's used in car infotainment systems. Plus, it's also used in the routers. Okay, where we expect a higher throughput. Plus, in the tablets also, and some of the smartphones, smart watches will use. In the car dashboard cluster boards will use this. So this is the unlock cluster, but in the unlock cluster, not Cortex A series is used. Rather, we'll make use of Cortex series, a digital cluster. Okay, the Cortex R series, as I told, it's used in the odd braking systems, and it's used in the airbag deployment, and it's also used in the hard drive controllers like Blu-ray players, you know, the media players, you know, in the industrial automation, where reliability and accuracy plus fast response are very much critical, and also used in the automobiles, and you know, in some routers also based on this. And the Cortex M series are used in the applications where the typically based on the microcontroller, like you know, the smart bands, so smart bands, you know, smart lighting, you know, many of the applications, washing machine, fridge, you know, oven, which are all based on the Cortex M series of microcontrollers. And as I told earlier, in the market there are many guys are there who are manufacturing Cortex M series of CPUs. Okay, so once again, ARM is not a silicon provider, rather there are other third-party silicon vendors are there whose job is to take the license of the Cortex CPUs and they will convert that as silicon. Okay, so yeah, guys, if you have any doubts, please ask me. You can stop me in between. Sir, am I audible, sir?
Sir, you're very much audible.
Okay. Yeah. Yeah. Now we'll concentrate on Cortex M series of cores. Why? Because as I told earlier, Cortex M series of cores by ARM company are very famous in the microcontroller market. In fact, many players are there who are giving the ICs which are based on the Cortex M series of core. Okay, when one among these silicon players is ST Microelectronics, In fact, in our department also, in the 4 semester lab, we are making use of the one microcontroller that is based on the Cortex M4 core. Okay, and in fact, telecom department, couple of other departments for their microcontroller lab, we are using the microcontroller that is based on the Cortex M4 core. Okay, so if you look at the journey of the Cortex M4 M series of cores, okay, it started with M0, then it's moved on to M7 with many intermediate variants. So as I told earlier, the ARM companies consistently upgraded its cores to match the diverse requirements. You take an example of the say electronic gadgets what we use in our day-to-day life. So these electronic gadgets in the earlier days used to come up with a keypad to provide a user interaction. To support a keypad, we can have a microcontroller that can support a keypad only. And you know that to interface a keypad, do not expect any special features out of the microcontroller. Okay, we should have a sufficient IO pins, and we should have a minimal processing to read the keypad value and provide that to CPU for the processing. As with days progresses, from the keypad, we moved on to touch screen. So now the microcontroller what is used in this application supposed to have support for touch screen, okay, plus reading the data of the touch screen and giving the data to processor for the processing. As the days progresses further, touch screen is changed to voice-based inputs. So that you have seen in the TV remote also. TV remote initially only keypads were there. Later from the keypads you migrated to the voice-based commands. Okay, look at the change in the microcontroller requirements in this example of remote. If it's only keypad, we should have a microcontroller with a sufficient number of IO pins. If the keypads change to voice-based input, okay, in addition to having a GPIO pins to support the keypads, we should have support for signal processing operations as well. Because we're giving the voice input or voice the signal, we expect the microcontroller to process that signal. So as our demands changes, the microcontroller features are expected to change to support these kind of diverse requirements. The ARM architecture, the M series of cores are consistently upgraded. That's what I'm trying to show using this slide. If you look at the Cortex M0 cores, Cortex M0, M0 plus with some of the variants of M3 are usually applied for the embedded systems where we can think of using 8-bit and 16-bit traditional application space. What's the meaning of that? You know that there are microcontrollers which are having 8 bits and microcontroller 16 bits also. Their traditional application space is like a TV remote where we expect to read the data and send to your TV, and might be a washing machine. In the olden days, washing machine will be not coming with too many operating modes. So there will be only keypad interface and it has to read the data from the keypad interface and send to the controller. Yes or no? So where we expect the lowest cost and the low area plus lowest power, that is the lowest power consumption, outstanding energy efficiency. Okay, so the Cortex M0 and M0 plus cores were most useful. In fact, these are applied to a traditional application space of 8 and 16-bit microcontrollers. What I mean to say is, traditionally where we can think of using 8 and 16-bit microcontrollers, we can use Cortex M0 and M0 plus cores. Okay, we can see. So there are many Cortex M0 microcontrollers which are of size 90 micrometers. Okay, and the battery, the life of this can be, I mean, this we are operating at a very low power. Even with the battery power, we can extend the lifespan to 15 years. So as we move ahead, we can say Cortex M3 Plus, in addition to having these features of low power, we wanted to have what is called as feature-rich connectivity. What's the meaning of that is, when IoT started booming up, we changed the architecture of the microcontrollers. In addition to having the IO connectivity, we expected it to have a rich set of connectivity so that we can connect our system to the internet and other stuffs. So this is where the Cortex M3 cores are very much useful. As move ahead from Cortex M3 to M4, we can see that application space changes. So in addition to having the features of M3, we expect the microcontroller support minimum signal processing operations, like processing a one-dimension signal like voice. Okay, as an example, you can think of Alexa speakers. The Alexa speakers are based on Cortex M4 CPUs. many speakers are there which are based on Cortex M4 CPUs. Why? Because so they're supposed to take our voice input and respond. That means we expect that guy to perform minimal processing as well. And the Alexa speakers, in addition to processing our voice input, it's supposed to connect to net also. So we need connectivity plus we need signal processing as well. To support this operation, they modified the Cortex M4 architecture to have signal processing operations, plus they also have what is called as SIMD operation, which stands for single instruction multiple data operations. Okay, as we move ahead of Cortex M7, we have optimized the performance to a greater extent, supporting DSP operation, supporting what is called as tightly coupled memory, supporting AXI bus. Okay, it's an improved version of the AMBA bus, supporting error control memory and supporting floating point operations. So Cortex M4 and M7, which are usually used for signal applications where we need microcontroller features plus signal processing operations. If you know about Texas Instruments, it's very famous in manufacturing one class of processors called digital signal processors. In fact, the mobile SoC, what I mentioned, it is having a signal processing core as well that come into picture when we want to make a call. That is when there's a requirement for processing a signal. Okay, but problem with the digital signal processors is they cannot provide connectivity like a microcontrollers. Other many applications are there in the market. They require connectivity like a microcontroller, plus they should have some signal processing capability also. So in those kind of applications, we can think of using Cortex M4 and M7 based microcontrollers. ST is microelectronics, very famous. It is manufacturing microcontrollers based on all these Cortex M series of cores. Okay, and there's one more thing is I try to benchmark the Cortex M7 core. If you look at this circle, the benchmarking gauge, it's a 5 core mark per megahertz. So what is this benchmarking gauge? You might be heard about MIPS, that's a million instructions per second. That's a one rating. This comes with the microcontrollers or processors to depict their throughput, that is how fast they are performing the operations. To specify that, we can make use of MIPS rating. It's a one number that says how fast the CPU is performing the operation. Like a 10 MIPS is, it can perform 10 million instructions per second. Okay, like that, there is a one famous benchmarking standard is there called a core mark. Okay, so the core mark what is provided by Cortex M7 core is 5 core mark per megahertz. So for if operate at 1 megahertz, it can provide a core mark of 5. So if operate at 20 megahertz, the core mark what it can provide is, let's say 5 into 20, that is 100 core mark. That's assuming that 20 is a maximum, 20 megahertz is a maximum clock frequency. We can operate Cortex M7 core. So the microcontrollers providing 100 core mark is a very high. Okay, I'm talking about the microcontroller market, because if you see the core mark rating of other CPUs, there are many processors are there which are used in the laptops and desktops whose core mark rating is more than 1 lakh is there. Okay. Yes, so in addition to these cores, ARM is also having other Cortex M series of cores, like Cortex M23 is there, M33 is there, M35P and M52, M55 and M85. Please try to understand all these cores are added to the basic Cortex M7, Cortex M series of core to support the ML kind of applications plus to support IoT kind of applications. So if you take ML kind of applications, as I told earlier, ML machine learning is a very computationally intensive operations. So if you're executing a one machine learning application which is having a multiple layers, if you assume even kernel size of maybe some 3 cross 3 or 6 cross 6, it's a basically basic operation is a matrix multiplication. So multiplication is one of the operation that usually takes a more number of clock cycles on microcontrollers. So if you're performing the multiplication of two matrices which are having more number of sizes, and these operations want to repeat among the multiple layers, then time that microcontroller would be taking to perform this operation will be more. To take care of that, they optimize the Cortex M series of cores to provide better throughput to execute machine learning applications. As a result of that, in the market, we have Cortex M85, M55, and M52 cores. Okay, these are especially meant for machine learning kind of applications on microcontrollers. That's a new trend that is happening in the market now. How can you port the machine learning application in the microcontrollers? Why? Because to perform machine learning applications, we cannot use the processors in the embedded applications. Because when you use the processors, other problems we need to take care. One major problem is power consumptions. So I cannot make use of a processor in my TV remote. Why? Because TV remote is very cheap, plus the power consumption is also a major issue. Okay. If I want to execute a machine learning on my TV remote, then I cannot make use of a processor. I need to execute a machine learning application on the microcontrollers only. Only option left with is option left with us is optimize the microcontroller architecture to execute the machine learning applications. So when it comes to M23, M33, and M35P, so these cores of Cortex M family are released to support IoT kind of application. In the IoT kind of application, in addition to having a better connectivity, we also expect connectivity plus the security. As we connect our system to net, the security is a major issue. To provide the security, we can think of two ways. One way is we can provide security at the hardware level, or else we can provide security at software level. So these cores are designed to provide the security at hardware level. What I mean to say is, these cores have a specific unit to perform error control coding, that is the CRC calculation, plus these cores are having what is called as trust zone to provide security. Okay, so with ARM has a wide product portfolio in all families to suit demands of the customer. Okay, so that's the reason why there are many silicon vendors are there who are taking the license of these ARM cores and providing and producing their own chips to uh, and releasing to the market. Okay, so moving ahead, so as I told, there's a one standard benchmarking is there called a core mark. Okay, what this core mark is? Before core mark, there was a standard called DMIPS, stands for dry stone million instructions per second. There's a one rating or one benchmarking standard used to specify how fast the CPU is. So if you want to select one CPU where have a multiple CPUs to select, what I need to check is we can see the DMIPS rating of the each CPU, and based on our requirement, we can select a suitable DMIPS CPU with suitable DMIPS rating. What I mean to say is, if I have two CPUs, if say one CPU has a DMIPS rating of X, other CPU has a DMIPS rating of Y. If I say X is greater than Y, then we can say that X is faster compared to Y. But there are certain problems are there with the dry stone MIPS. The standard was used for so many days. To take care of these problems with the DMIPS, there was one consortium formed called a core mark. There are many companies are joined together and they came up with a one standard called a core mark rating. So core mark solves many of the problems which are there in the DMIPS rating, that is MIPS rating. So core mark is a one number used to indicate how fast our CPU is. In fact, you can browse in the Google. There's a one website is there that gives information regarding core mark rating of different CPUs which are there in the market. So based on this rating, it's possible to identify which CPU suits our requirements. So once again, if you have a CPU with a higher core mark rating, that is said to be faster compared to other CPU which has lower core mark rating. That's a number to indicate how fast the CPU is. Okay. In addition to the core mark and DMIPS, there are other benchmarking standards are there in the market. For example, there is one benchmarking standard like TPLOPS is there, TLOPS, tera floating point operations per second. In fact, that's also used to specify the speed of the microcontrollers. There is a one more standard called million max, ACS. That's also used to specify the speed of the CPUs. Plus, there is a spec int 16 is there, and spec floating point is there. Okay, and all these can be used to specify the speed of the CPUs. So moving ahead, so there is a different instruction versions are that ARM company is making. What I mean to say is, uh, so they will, to match the requirements of the different applications, they are upgrading their ARM companies consistently upgrading their instruction set. That's the reason why in the market we have a different instruction set versions of the ARM. Okay, starting from ARM V4. Before that, there is a V4 is there. So V4, that ARM7, which belongs to V4. So in this figure, I'm starting from V7. Okay, I try to explain different features which are there in different instruction versions of the ARM. Okay, from V5 to V9. So in the many of the CPUs that are there in the market now, like Cortex A series, A72 or belongs to V9A, and the Cortex M4 and M3 what I discussed, it belongs to V7 and V6, and Cortex M7 and M85 belongs to Cortex V8 M, where A indicates A series, R indicates R series, and M indicates Cortex M series. What I mean to say is, so they have their own instruction set architectures, which is called ISAs of different Cortex processor families. Okay, I'm not getting into the finer details of these instruction versions because it's a elaborate lecture. So what I can say is, so the ARM is consistently upgrading to match the requirements of the industry. For example, if you look at the V9A, so it has all the features of V8A, plus it has a support for security, ML, and DSP. What's the meaning of that is, in the assembly instruction set, in addition to having the basic arithmetic and logical operations, it has an instruction to perform security operations, ML operations, and signal processing operations. When I say signal processing, one famous operation is multiply and accumulate operation. And to provide multiply and accumulate operation in the assembly instruction, there is MLA is there. So they improved the capabilities of the MLA in the V9A. Similarly, if you look at a V8A, it is having arithmetic and logical instructions. Plus, it has a separate instruction to perform cryptographic operations, like the calculation of the CRC, and the performing scalar floating point operations, and single precision floating point operations, and double precision floating point operations. Many things are added. Okay, and in the V7A, so it has all arithmetic and logical operations, plus it has the SIMD instruction plus floating point operations. Okay, so the Cortex M4 belongs to V7 as I told earlier, and M7 and Cortex M85 belongs to V8A. Okay, and as I told, there are many key players who are making use of these ISAs to manufacture microcontrollers, and there are many guys are providing the tools which can be used to develop the applications based on these CPUs. Okay, and then yeah, so this is my last slide. What I'm trying to show is, so in our department, in the first semester lab, we are making use of ARM Cortex M4 based microcontroller, that is STM32F407VG. It's a famously called as STM32F4 Discovery. It's one board called STM32F4 Discovery board that is based on Cortex M4 microcontroller given by ST Microelectronics. Okay, so among the student community, you must be knowing that so Arduino and Raspberry Pi are very famous. Now these ST microcontrollers are gaining their momentum among the student community. Why? Because to program these ST microcontrollers, there is a one software called STM32QMX is there. Using this, very easy to program. What I mean to say is, I think you guys have experience of programming LPC214, right? I think you are using register to program it, or else you will be making use of the functions available in the library. But if you use a STM32QMX to program ST microcontrollers, it's a one graphical user interface where all the pins can be configured very easily as I shown towards right hand side of the slide. It gives a IC like this, and as per our requirement, I can configure the different pins by selecting the options in the drop down list. Later, I can generate the initialization code in one click of the button, one click. So generate code, initialization code will be generated, and using that initialization code, I can concentrate on developing my main function. So user only concentrating more about developing the application code rather than developing the initialization code. Yes or no? If you know about the microcontroller programming, we spend more time in programming the peripheral, initializing the microcontroller units to perform our operations. So if you use a QMX, all those time can be reduced. Why? Because programming the peripherals using this QMX is very easy because a graphical user interface. Plus, this QMX tool has other options also. It gives us clock configurations we can do. We can develop the projects which can run in Keel or IAR STMQ IDE. It's possible to perform power consumption estimation. And also, we can include real-time operating system into this QMX also. Okay, so this is what you're doing in a first semester lab, making use of ST microcontroller, and we are using QMX to program its peripheral and developing application code. So you're using the same microcontroller in the next semester embedded system course, so where we'll port real-time operating system onto this microcontroller. Okay, so guys, whenever you get a time, browse in the Google STM32 QMX software. It's a open source, it's a royalty-free software. It's a free software, anybody can download. They can start developing the applications without knowing the finer architecture of these microcontrollers. Okay, in fact, industry never expect you to know the architecture in great detail. It's okay, but they expect you to know how can you develop the applications on this by knowing what I mean to say is some abstract information regarding the microcontrollers, right? Okay. Sir, I think that's all from my side. You have any doubts, please